what were we discussing in the previous class? So we stopped with zero matrix, right? Now we'll discuss about equality of matrices. Okay. So two matrices, A is equal to Aij and B is equal to Bij, are said to be equal if they are of the same order. Okay. Similarly, each element of A is equal to the corresponding element of B, then Aij will be equal to Bij and I will be equal to J. So, whenever you want to define the equality of two matrices, right, the first thing is the order of the matrix is supposed to be same. They never mention it to be a square matrix in the first place. So, order of the matrix needs to be the same. For example, if I take 2, 3, 0, 1 and 2, 3, 0, 1, we can obviously call them as zero matrices. But if you look at this thing, 3, 2, 0, 1 and 2, 3, 0, 1, can we call them as equal matrices? Because the corresponding elements in the ith row and the jth column are not the same. Okay. So, yeah, tell me. Repeat it again. Just 2 minutes only to get charged. Tell me. 3. Okay. 2, 3, 0. Where all the elements are same. Which one is a 3? Two, 3. Which this is a 3 cross 3 is what it is. It is not 3 cross 3, no? No, they cannot. Because we don't have information about these elements and these elements. Right. Okay. So symbolically, if you want to represent two matrices to be equal, then A should be equal to B. So if you take XY, ZA, BC, this is equal to minus 1.50, 2 root 6 and 3, 2. Okay. Then X will be equal to how much? Compare on both the sides. So is it not something similar to equating the ordered pairs in a set, or comparing the real parts in complex numbers and imaginary parts in complex numbers? It is something similar only. You compare the numbers. So x will be 1.5, y will be 0, z will be 2, a will be root 6, b will be 3, c will be 2. Okay. So let us take this example 4. Okay. So let's take this example 4 and then solve. You guys do it first. Are you done? So if you're done, go with the next one. Go wait for it. So what is the answer here? X plus 3 is 0. So x is minus 3. Z plus 4 is 6. So z is equal to 2. 2y minus 7 is equal to 3y minus
y equal
2.
to minus 5.
Y is equal to minus 5. So minus 6. A minus 1 is 3. So A will be equal to minus 2. 2c plus 2. So C will be equal to minus 1. B minus 3 and 2b plus 4. So B
minus
will be
7.
correct. Minus 7. Minus 1. That's it. Find the values of A and B, find the value of A, B, and C, and from the following equation. So 2a plus b is 4. A minus 2b is minus 3. Correct?
A is 1.
B is 1.
A is 1, sir. B is 2.
Okay, then we'll multiply this with 2, then it becomes minus 6. So 5b is equal to minus 2. So b is minus 2 by 5. Huh?
Sir, I got B as 2.
No, b as 2, correct. Sorry, I made a mistake. Is a 10, so b will be equal to 2. So when b is 2, 2a will be equal to 2, a will be equal to 1. Correct? So 5c minus d will be 11. 4c plus 3d will be 24. So 15c minus 3d is equal to 33. Add them. 19c will be equal to 57. C will be 3 and D is 4. So they are exactly in order. 1, 2, 3, 4. Okay. Can we solve this exercise fast? So first one, what is the answer? Order of the matrix. 3 by
4.
number of elements. Well, 3 into 4, 12. Write the elements A1, 3. First row, third column. 19. A21. Sorry, 21. Second row, 35. 33. That is 3, 3. A24. Second row, fourth column, 12. 2, 3. 5 by 2. Okay. The matrix has 24 elements. What are the possible orders it can have? All the factors. So 25, what are the factors? 124, 212, 38, and 46. And the reverse of them. So totally how many matrices will be?
6.
8, no? You'll have 8, no? 24, you'll have 124,
Yes, sir.
212, 3, 4, sorry, 3, 8, and 4, 6. Now the reverse of it. 6, 4, 8, 3, 12, 2, 24, 1. So how much will be the answer? It will have 8 matrices. What if it has 13 elements? 13, no? 13 is a prime number. 113 or 13. So it will have only 2 matrices. Can we go a little faster? It's an easy exercise, right? The matrix has 18 elements. What are the possible orders it can have? 118 or 81, 29 or 92, 36 or 63. That's it. So it will have 6 different matrices. What if it has 5 elements? So again a prime number 1, 5 and 5, 1. Construct a 2 cross 2 matrix where A is equal to Aij whose elements are given by Aij is equal to I plus j the whole square divided by 2. So what will be the elements? 1, 1, 1, 2, 2, 1, 2, 2. Correct? You will have A11, A12, A21 and A22. Anybody needs help with this? So what is the answer for the first one? 2, 9 by 2, 9 by 2,
8.
8. So the answer for this will be 2, 9 by 2, 9 by 2, 8. What is Aij is equal to I by j? 1,
1 1 by 2 2 1.
1, 1 by 2, 2, 1. I plus 2j the whole square. Nine by two. 9 by 2. 8 and construct a 3 cross 4 matrix whose elements are given by. So remember, it is a modulus, so all values are expected to be positive. So answer for the first one. Half into minus 2. Sorry, plus 2. No? 2, 1. Oh, oh you multiplied that half itself. 1. Oh. So you have 0 1 by 2. Then 2i minus j. One zero 3210 3 cross 4 tanama. Find the value of xyz from the following equation. So y is obviously 4, z is 3, x is 1, and 5 is obviously equal to 5. What about this thing? X plus y is 6, xy is equal to 8. Then how do you find x and y? 2 4 or 4 2, but which one is right? How? You are getting both the answers, huh? Then it's okay. So the way to find is x minus y the whole square will be equal to x plus y the whole square minus 2xy, correct? So 36 minus 2 into xy is 8. So you'll get 20. 36 minus 4. So x minus y will be equal to plus or minus 2. Okay, you will get both. But is this the way you solve? You would have got a quadratic equation and then you have to solve it. You take y is equal to 8 by x, substitute it back, then you get a quadratic. Is that the way you solved, or you use trial and error? Trial and error, what if it goes wrong? But did you understand the method which I followed?
Yeah.
So whenever you have x plus y and xy, right? So x plus y is 6, xy is 8. So x plus y or x minus y the whole square. So how much is this? 36 minus 4 into 8. That will be 4. So x minus y is equal to plus or minus 2. Okay. So x plus y plus z is 9. X plus z is 5. Y plus z is 7.
Sir?
So
Sir,
x
in
is
the
2. X is 2.
Sir,
Ah,
sir, in the before sum, sir, we can directly use like xy is equal to 8. So x is 8 by y. Then
yeah, you can use
substitute.
that. You can use that. X is equal to 8 by y. Take this and substitute it here. 8 by y plus y is equal to. So that's what I told you. You'll get a quadratic equation. Y square minus 6y square minus 6y plus 8. Okay. Now you will have
Y is equal to
minus
4 or y equal to 2, sir.
correct. So when y is 2, x will be 4. When y is 4, x will be 2. Understood, Nitish?
Yes, sir.
So what about the third one? X plus y plus z is?
Sir, Z12 is 3, sir.
Sorry?
Sir, is Z value 3?
I'm not sure. I have to check that. So y plus z is 7. So I'll take, so y plus z 7. Okay, this is 9. I'll put 7 here. Then x will be 2. Correct?
Yes, sir. X is 2, Y is 4.
Then z will be 3. Upper y will be 4. Find the value of a, b, c, and d from the equation. A minus b is minus 1, 2a minus b is 0. So 2a is equal to b. So a will be equal to 2a. A can be any number. No. A will be 1. For which one? A can also, I don't think. You will have only one, no, because it's linear equation in 2 variables. So a minus b is minus 1, 2a minus b is 0. You will subtract both, no? So minus a will be minus 1. So a will be 1. If you add both, you will get 3a minus 2b is equal to minus 1. Yeah. See, linear equation in 2 variables will have only one solution. Clear? So I hope it is simple only, right? Is there anyone having problem? Got it. Those who are online, I hope everybody solved it, right? Next. Oh, you have few more problems. What about 8? Square matrix M should be equal to n. Which of the following, which of the given values of x and y make the following pair of matrices equal? So x will be equal to minus 7 by 3 and y should be equal to 7. No option. Oh, they didn't say equal to. X has two values, sir. So y plus 1 is 8, y is equal to 7. 2 minus 3x is equal to 4. X has two values, so not possible to find. Not possible to find because they are not equal matrices. Now you tell me the number of all possible matrices of order 3 cross 3 which have entry. See, 512. How did you get it?
2 power 9.
Yes. So those matrices should have only zeros or ones. So number of elements entries are 2 and the number of spaces you have is 9. So 2 power 9. Okay. So having said this, we saw the basics of what matrices are and how our equal matrices and different kinds of matrices are drawn. Right. Now next we'll see the operation on matrices. So in this section, we'll introduce certain operation on matrices, namely addition of matrices and multiplication of a matrix by scalar. So it is not multiplication of matrices itself. If you take a number and multiply that matrix with that number, then how is the matrix going to change? Similarly, you will find difference and multiplication of matrices. So what I'm trying to tell you here, there are two cases where multiplication is used. So what is the first one? Multiplication of a matrix by a scalar means a matrix is multiplied with a common number. What is multiplication of matrices? Means two matrices are given to you and you need to multiply those two matrices and find the new one. Okay. Next is addition of, so first one we'll see addition of matrices. So they have given some examples. We'll go with the example itself. Suppose Fatima has two factories at places A and B. Each factory produces sports shoes for boys and girls in 3 different price categories labeled 1, 2, and 3. The quantities produced by each factory are represented as matrices given below. So in factory A, what are they doing? They are manufacturing shoes for whom? For both boys and girls, and those shoes are categorized at different price levels. Okay. So for boys in factory A, in category number 1, there are 80 shoes. Correct? Shoes only, no? Here 60 shoes, 75, 65, 90, and 85. In factory B, 90, 50, 70, 55, 75, 75. Okay. Now you want to find the total number of shoes that are produced under category 1, 2, and 3. What will be? Will you not add them? So why are these two considered as different scenarios? So if you observe, right, the whole entity or the whole factory is under the name of Fatima. Why is she having two different factories? Because based on the requirement, some manufacturing is done at place A and some is done at place B. But if you see as a whole, right, whatever shoe is getting manufactured in factory A under category 1 will be the same shoe getting, will be a similar shoe, not the same, will be a similar shoe getting manufactured under factory B under the same category. So how many shoes is the factory as a whole is producing is what is the question. Okay, that is the meaning of it. But if you look in a simpler perspective, what are we supposed to do? Add them. Then what will you get? You will get total as how much? 170, 110, 145, 60, 120, 90 plus 75, 165, 75 plus 85. 130. +80 plus 70 is 150 plus 10. So it is 160, correct? So these are the total number of shoes that are manufactured under Fatima's factory itself, whether it is at place A or place B. Okay. So how will you represent them? It is the sum of those two elements. How did you arrive at 170? It is because you added the corresponding elements. You didn't add this 80 to this 50, right? You added the corresponding elements belonging to the corresponding rows and the corresponding columns. So from this, can we try to give a definition to matrix addition? So the new matrix that is formed is the sum of the above two matrices. We observe that the sum of the two matrices is a matrix obtained by adding the corresponding elements of the given matrices. Furthermore, so the answer to your question. Because what you're doing, see, imagine, forget about matrix, okay? You have worked in Excel, right? Let's say you're working under Excel where you're putting this column and this column, right? When you try to add them, will you try to write them of the same order or different order? Like one place you will try to write vertically, one place horizontally. Will that work? Right? So it is the same case that we need to follow here. Okay. So A is equal to, if I say A11, A12, A13, A21, A22, A23 is a 2 cross 3 matrix. Then B is also another matrix of the same order 2 cross 3. Then when you add them, right, then what is the order of the output matrix that you're going to get? That will also be of the same order. This is an important point to be noted because when you multiply two matrices, right, the rules will change. Are you able to understand what I'm trying to say? So the output will also be of the same order. So can you do an example? Do it faster. A is equal to root 3, 1 minus 1, 2, 3, 0. B is equal to 2 root 5, 1 minus 2, 3 half. A plus B. So root 3 is an irrational number, 2 is a rational number. When you add them, you will get an irrational number. So 2 plus root 3, 1 plus root 5. Got it? So here there are certain important notes. So we can emphasize that if A and B are not of the same order, then A plus B cannot be defined at all. Leave about finding them, cannot be defined. For example, you have 2, 3, 1, 0, 1, 2, 3, 1, 0, 1. You cannot define it at all. Secondly, we observe that the addition of matrices is an example of binary operation on the set of matrices of the same order. Binary operation, addition, subtraction, all these things are going to talk about. Okay. Shall we go on to the next one? Can I go a little fast? Yeah. So multiplication of a matrix by a scalar. Suppose the same example that Fatima has doubled the production at factory A in all categories. Okay. Then what can you write it as? Previously, the quantity is in standard units, whatever units, I'm not concerned about it, produced by factory A where for boys and girls, the corresponding value were 80, 60, 75, 65, 90, 85. Now she has seen that the sales has grown up, okay, and she wants to double the production value. Then what will she do? So she will double all the value to 160, 120, 150, 130, like that. It keeps on going, right? So instead of multiplying each value with the number, is there a direct way with the help of matrices that you can write it? So what you can do is you can take that scalar value 2, and the 2, if you write it as A, suppose I call this matrix as A, then 2 times A represents what? So 2 times A means that the number 2 is multiplied with every element present in that particular matrix. Why I'm stressing here is, you know what is the third chapter's name? Matrices, right? What is the fourth chapter's name? Determinants. Is it raining? Okay, when I talk about determinants, right? When you multiply determinant with 2, it will not get multiplied with all the elements. Whereas in this case, in a case of a matrix, if you multiply a matrix with a number, it gets multiplied with all the corresponding elements. Is that clear, guys? Okay. So this, so how you revised quantities produced by factory A are 2 into 80, 2 into 60, 2 into 75, 2 into 65, 2 into 90, 2 into 85. So it will be this one. So now we observe that the new matrix, how did we obtain it? Based on the case study, we obtained it by multiplying each element of the previous matrix by 2. So it is the same. So in general, if you want to define the multiplication of a matrix by a scalar, if I have a matrix A, which is written as Aij of the order m cross n, is a matrix, and if K is a scalar, that scalar can be anything, it can be positive or negative. Then that K When you multiply it with the matrix, how do you write it? Scalar times the matrix name A. Okay, is another matrix which is obtained by multiplying each element of A by the scalar. Please underline that word, each element. You guys have umbrella? You guys have umbrella? You can write next. Might or might not, who knows? Let's see. But there will be a solution. I will find it out. So A is equal to 3, 1, 1.5. I have root 5, 7 minus 3, 205. Correct? So if I want 3 times A, what am I supposed to do? Multiply the 3 with every element of the matrix. So what will the answer be? 12, 3, 4.5, 3 root 5. Oh, 9. Sorry. 9, 3, 4.5, 3 root 5, 21, minus 9, 6, 0, 15. Correct? Suppose I multiply matrix with minus 1. What can I call that matrix with respect to the original matrices? I can call it as an additive inverse. Because what is an additive inverse? A number added to a given number so that the output is 0. Okay. So negative of a matrix is denoted by minus A, and minus A can also be written as minus 1 multiplied with A. Easy, right? Seventh example is a combination of both. Do it fast. A is equal to 1, 2, 3, 2, 3, 1. B is 3 minus 1, 3, minus 1, 0, 2. Then find the value of 2A minus B. Two, 4, 6, 4, 6, 2 minus B is 3 minus 1, 3, minus 1, 0, 2. So what will the answer be? Minus 1, minus 5, sorry,
Sorry.
minus 1 plus 5, no? 3, 5, 6, 0. Minus 1, 5, 3, 5, 6, 0. Correct? So next is properties of matrix addition. Okay, it follows, the first thing is commutative law. What is commutative law state? A plus B is the same as B plus A. Two matrices of the same order A and same order M cross N are given to you. Then A plus B is the same as B plus A. Then what is the second law? Associative law. What does it state? So if you add A plus B first and you add it to a third matrix C, it is the same as adding the first matrix to the sum of the other two matrices. Correct? Next is existence of additive identity. So what is it? Additive identity is different from additive inverse. I hope you know the difference. What is additive inverse? Negative of a given number is additive inverse. But what is additive identity? Additive identity is a number which you add to a given number so that you get back the same number. So which number can you add? 0. So 0 is called as an additive identity. Similarly, if I call something as a multiplicative identity, what should I say? 1. Because if I multiply that with a matrix, I should get the same output. Is that clear? So existence of additive identity. If I take A as a matrix of order M cross N, and let's say 0 matrix is of the same order M cross N, where every element of the matrix is 0, then A plus 0 is equal to 0 plus A is A. In other words, 0 is called as the additive identity for the matrix addition. Similarly, if I talk about existence of additive inverse, this I already told you. A is a matrix of order m by n. Then what will be the additive inverse of it? Negative of A of the same order m cross n. So that A minus plus of minus A will give you a zero matrix. So always remember, if you add a matrix to a matrix, you should get only a matrix. Most of the time, what will happen is people tell me that I get zero. Zero is a number. Zero matrix is a arrangement of data. So when you add a matrix to the additive inverse of that matrix, you will get a zero matrix. Never forget that word, okay? So properties of multiplication, properties of scalar multiplication of a matrix. Okay, so here it is a combination of multiplication and addition. Suppose I take K to be any scalar. Okay, K and L are scalars, some numbers. I have two matrices A and B. I find value of A plus B and multiply it with K. By doing it, it is the same as multiplying the K with matrix A first and multiplying the K with matrix B first and then adding them. Okay. Secondly, if I have K plus L into A, then it is the same as multiplying K with A separately, L with A separately, and adding them separately. Okay. Similarly, K times A plus B will be equal to, oh, there is a proof. That's it. Okay. And the third one is K plus L into A. So what are they written? It's the same thing again, proof. Okay. Now having this in mind, let's do example number 8. A is equal to 804 minus 236. B is equal to 2 minus 2, 4 to minus 5. Then find the matrix X such that 2A plus 3X is 5B. So there are two ways to solve this. Can you guys tell me how to solve? One of the ways is consider matrix X to be XY something like that of the same order as that of A and B, and then proceed. Or else we can go with the properties. You want me to do this? So 2A plus 3X is equal to 5B. Right. Now what you can do is, see, listen to this carefully. I want you to listen. I know if you add, you can take this 2A to the other side, right? Is that what you thought of? Because you're looking at it like numbers, right? But generally what we will do is, left hand side, if you want that matrix to go to the other side, you should always write adding the additive inverse of it. Okay. So 2A plus 3X minus 2A is equal to 5B minus 2X. Means I'm trying to say I'm adding minus 2X on both the sides. Sorry, 2A on both the sides. So that this and this will get cancelled. Now what will I get? 3 times X is equal to 5B minus 2A. Now what you will say is dividing with 3 on both sides. Instead of saying dividing with 3 on both the sides, you can say multiplying with 1 by 3 on both the sides. Both are same. So when you do that, X will be equal to 1 by 3 into 5B minus 2A. First come to this step, then do it. Answer. What is the answer, guys? You got it? Huh? So those who are online are able to do it? Yeah?
Minus 2, minus 10 by 3, 4, 14 by 3. Then minus 31 by 3 and
So
minus 7 by 3.
minus 2.
Minus 10 by 3.
Okay.
Then 4, 14 by 3.
Okay.
Then minus 31 by 3 and minus 7 by 3, sir.
This is what everyone got?
Minus 7 by 3, sir.
Enga minus 7 by last.
Yes, sir. A32.
Okay. But now you know how to do it, right?
Yes, sir.
Yes. Let's look at example number 9. Find X plus Y if X plus Y is equal to 5. Find X and Y if X plus Y is equal to 5209 and X minus Y is 360 minus 1. So what will you do to them? Add both the linear equations. Then what will you get? You will get 2 times X is equal to 2 times x is how much? 8, 8, 0 minus 8. Sorry, 8, 8, 0, 8, correct? X will be equal to how much? What can I do to that 8?
4404.
I can take that out, 1, 1, 0, 1. So x will be equal to 4404. Correct? What about y, guys?
Sir, 1 minus 205.
Everybody knows to do this, right? So, example 10. Do it fast.
Sir, I got x2 and y4.
Correct. I'm not checking the answer. Everyone got that x2, y4. So you'll get 2x plus 10. Sorry. 2x 10, 14, 7y minus 21. Uh, 2x plus 3, 7. So 2x is equal to 4x, so 2. Correct? 7y minus 19 is equal to 14. So 7y is equal to 19 plus 14. Oh, 2y minus 6. I multiplied with 7. So 2y minus 6 is 14. So 2y will be equal to 20. Oh, plus 2. Up 2y minus 4 is 14. Correct? Up 2 by x is y is 9. Okay. Now let us see example 11. How to convert a given statement into a matrix form and then solve it. So there are two farmers, Ram Kishan and Gurucharan Singh, cultivates only 3 varieties of rice, namely Basmati, Permal, and Nora. Okay. The sale in rupees of these varieties of rice by both the farmers in the month of September and October are given by the following matrices. Okay. So A is equal to Basmati PN. So Basmati in rupees is 10,000. This one is 20, 30. For Gurcharan Singh, it is 50,000, 30,000, and 10,000. Okay. Similarly, in the month of October, I will represent it as matrix B. 5,000, 10,000, and 6,000, 20,000, 10,000, and 10,000. Find the combined sales in September and October for each farmer in each variety. So how do we find the combined sale? Add them. So what will be the combined sale? So 15,000, 30,000. And 20,000. Correct? Find the decrease in sales from September to October. So you need to subtract them. So when you have to subtract, you'll have 5,000, 10,000, 24,000. then 30,000, 20,000, 0. So there was no drop here. If both the farmers receive 2% profit on gross sales, compute the profit for each farmer and for each variety sold in October. 2% means how much? 2 by 1 by 50. So they're asking the profit. So final price is how much? Final price is 50,000 only. So how will you calculate the profit on it? So you will calculate the profit as 1 by 50 into 5,000, 10,000, 6,000, 20, 10, 10. Correct? Huh? So how much will it be? $120. Yeah. 200 and 200. So this is the amount he has got it. Correct? Huh?
Sir,
That's a just profit. Huh?
sir, why it is 1 by 50?
Was 2%. 2%. 2 by 100. La?
Okay.
Is it clear? Multiplication of matrices, we can see the next steps. So those are online. Any doubt, guys? Okay, then we'll wind up.
Sir,
Yeah, tell me.